To begin, this video is a makeup for a missed field trip assignment, lab assignment for geology of the national parks at Southern Utah University class. Through this video, we're going to explain how and what different features are found in Zion National Park and how they came to be. And some of these photos are going to be sideways. The way they were converted onto the editor wasn't good, and just kind of have to tilt your head. So we started by driving down the I-15 and stopping at Kolob Canyon area of Zion National Park, it's the northern end. We then drove up the scenic route, which is about 5 miles long, climbs quickly up the backside of one of the rifting zones, which we'll address later. And we started in a great example of the here of the Earth. It's exposed in the video. You can see due to the glare from the sun coming up over the ridge there. But the kebab layer is the oldest layer found in the park, dating back to about 270 million years ago, plus or minus. Originally, this layer was part of the west coast, the west coast of when Utah was the west coast of this area of the world. This layer, there's been many fossils found in it, and they vary from size, from small to medium. The layer, just butchered that name. Driving into Zion National Park along Interstate 9, there are many places very close to the road where this layer can be observed. When you see this layer, it's a reddish brown and has large solid portions. However, when you get up close to it, it has thin lines of layering. It is also, it protrudes a lot in the area around Zion. You can see it sticking out of the side of the hills and the mountain tops. And also, in some, it's actually 1,000 feet thick, or 1,000 feet deep, that you can see. And so third is the Chinle. Is the third oldest layer. I forgot to mention earlier, working from oldest to youngest through the layers. The Chinle Formation layer is 210 to 225 million years old. That's the best estimate. It's common that this layer has two parts, an upper portion and a lower portion. A little bit more detail about the lower portion. It's more of a conglomerate. It's cobble rock based. It's many different types of rocks, kind of like glued together. Is mostly petrified forest composite. It's got a lot of petrified wood is found in there. Spruce, I believe, was one of them. The most common, actually. And so the formation of these layers in the Chinle Formation, the lower layer was formed by fast-moving streams, and so it's got a little bit more of the fine grain. It's kind of where the conglomerate comes from. The upper portion is created by low-speed rivers, and they deposited more of a mudstone that the petrified wood would have been stuck in as it floated down the river. And then the layers, you can kind of, usually towards the top, you can see the bright gray. That is actually ancient ash from volcanoes. The ash was carried down by the rivers and the streams. Then you have the Navajo sandstone. So the sandstone, and sorry about the photo again, the way that it uploaded just didn't work. So the sandstone, you have 2-3 layers before it, and then boom, it just gets dumped with a whole bunch of sand for a couple million years. And over time, that sand compresses and it crossbeds. And it becomes one solid, sturdy mass. And then from there, weathering and erosion comes in through the wind and the rain and cuts it out, and that's where you get the valleys and the narrows and so forth, which we'll go into later. But the sandstone in Zion is about 180, 185 million years old and is very, very, very deep and very, very large, depending on what area of the park you're in. So, Dome is the highest point in the main portion of Zion National Park. It's mostly consists, as you can see, of sandstone, and then off to the side, down the left-hand side of the photo and the right-hand side, is the gray ash from the Kinley layer, and then at the very top is the caramel formation, which is kind of like the cap of everything, just kind of sits there on top. But as you can see, what's interesting, eroded away the sides of it, leaving just that nice, almost like a cork on the top of it. Then there is the erosion that occurs in Zion National Park. In 1995, the area you see here, again the picture's tilted, you mentally rotate that to the left, it's oriented properly, but the rock fell. They had a rock slide, it came down, and then the Virgin River, which runs just on the other side of that brick wall there, started washing away that sediment. Well, due to the rock slide, it also pushed the river over and started coming underneath the road that rock wall is on, and subsequently the road collapsed along with the sediment that was being washed away from the rock slide, and then it ended up leaving about 100 people stranded at the lodge in Zion, which is further up the road, for 2 nights until they could safely get them out and retrieve their belongings. Then we have the Narrows. The Narrows are created by the Navajo sandstone and the Virgin River running through or on top of and cutting down the Navajo sandstone. So the river, as it runs, it washes away little bits. It brings sediment down that chips away and scratches away the sandstone, and over the course of a couple million years, hundreds of thousands depending, it washes away and it creates the Narrows. Now the Narrows is the water gets funneled through tightly and it just eats away its own little path through the sandstone until finally it breaks through to another open ground area where it continues its path. So at one point there was probably a waterfall in there, or small waterfalls. You have an example of that with Canaryville Falls and Tokerville Falls a little bit too as well. So then we have the 3 patriarchs, as they're called. The 3 patriarchs are the 3 mountains you see in the photo there. They're named after the 3 patriarchs of Judaism, Abraham, Isaac, and Jacob. And they're all sandstone cliff faces, basically. They are, I think the biggest one caps out at just about 6,800 feet above the valley floor, and that is quite a ways up. And as you can tell, between them, they have a little bit of a hanging valley side, and it's over time gotten lower and lower until eventually it's almost all the way down, but it's still a hanging valley. And then continuing, there's the rest of the photos of the beginning to the narrows. Unfortunately, due to the river levels, we weren't able to actually go in there. We got as close as we could before we were forced to turn around. So, uplift. Uplift happened in Zion area. Plate came underneath the other and then pushed up, and now Zion wasn't created with a fast, quick lift. It was a slow, kind of methodical. You can kind of see the change in the dynamics of the geography in this photo. From the strut of the airplane wing, as it comes down, it gets flatter and flatter, and then underneath the airplane there's actually another rise. That's kind of one of the areas where it pushed, and then it moved, then it pushed again, creating the area in the photo. This is a little bit better photo. You can see the valley floor and then where the last lift really occurred, being kind of more to the right and moving to the left, where the mountain kind of begins going up and along with the rest of the land.